Okay, math models, I'm going to do the same thing I did yesterday and work a couple of these problems in the packet for you. Hopefully that'll help you get going, and you should be able to work on this the rest of class. There shouldn't be any reason you can't finish this in class today. If you're working and doing what you're supposed to be doing, you can get this finished. A lot of you have been slacking off, and that's going to be reflected in your grade. So make sure you're doing what I'm asking you to do, and everything will be okay. So starting off here, it says direct variation functions. It says that y is equal to kx. Anytime you hear the words a direct variation, it means something is multiplied times something else. K is the constant of proportionality, and that's the same as the slope of a line. Okay, so the first problem here says that y varies directly as x when y equals 9 and x equals k, or x equals 15, sorry. So you're going to use the same formula on all these that says that it varies directly. Y equals kx. So you're going to plug in the numbers that they give you. So they said that y equals 9 when x equals 15. So I write 9 equals k times 15. And then I'm going to solve for k. So to get k by itself, we're going to divide by 15 on both sides and find out what k is equal to. So in your calculator, if you need to do 9 over 15, you can do that and then change it back to a fraction. We always want our fractions reduced. So k reduces to equal 3 over 5. Okay, so if k is 3 over 5, then the equation for this function is just y equals 3 over 5x. Okay, so you solve for k and then plug it back into that original equation. Then they're going to ask you some questions to use that equation and find out other values. So now they want to know when x equals 10, what does y equal? So y is going to equal 3 over 5 times 10. So if you need to type that in your calculator, you can, but this would be 3 times 10 is 30 divided by 5, and that's going to equal 6. Okay, so anytime you see that y varies directly as x, that means it's a direct proportion, and so you're always going to use the equation y equals kx. Plug in the information that they gave you into that equation, solve for the k value, then you can write the equation. Okay, you should be able to solve for anything that they give you once you have that equation. Okay, I'm going to jump down to number 4. Number 4 says the point 26 is in the graph of a direct variation function. Fill in the missing numbers in these ordered pairs that are contained in the same line. So if they're saying that y varies directly as x, that means that y equals kx again. So we plug in the numbers that they gave us. They said that y is 6, we don't know k, and x is 2. So if I solve for k, k is going to equal 3. So the equation then, y equals 3x, is my equation for this function. Okay, so what I'm going to do is I'm going to hop over here on the calculator, and I'm going to show you a few things on the calculator that you can use to help you solve this problem as well. So if I go to y equals on my calculator, I've got some other equation in there. I'm going to go ahead and clear that out, and I'm going to type 3x in y equals. I don't need to graph it. I don't need to know what the graph looks like for this. On this problem over here, they have some ordered pairs that they want us to fill in. So I'm going to go to the table on my graph. So I'm going to hit second graph, go to the table. So not all of the numbers listed are going to be the numbers that they're asking me for. So this is just going to be the standard table. There's going to be numbers, usually integers, that are listed in x, and then they give you the y values. So one thing that you can do to change that is, first we could look for some of the values that they already have y values for. So like the second number, they want to know what is the x when y is equal to 12. So if I scroll down here, I can see that y is 12, x is 4. So that's one answer that I could find. But not all of them are listed in here. So one thing that you can do, you could always just plug the numbers into the equation, y equals 3x, and find the missing problem. Here's something else. If you hit second window, and we're going to change this independent option to ask. So I'm going to go down 2 times, go over to ask, and hit enter. And then I'm going to go back to the table. Okay, now I'm not going to see any values because I'm going to put in some values here. So I'm going to try 1.5, and I'm going to hit enter, and the answer is 4.5. I'm going to try 2/3 and hit enter, and the answer is 2. Okay, so this feature only works if you're typing in the x value. You cannot type in the y value and it give back the x value. So if you want the x values when you're given y, you need to do that algebraically. So it's a little bit of a cheat, but not much. So for example, we've already found 1.5 is equal to 4.5. And then we found 2/3 was equal to 2. Earlier, one of the other was in the list as well. So remember, our equation was y equals 3x. So if I want to know what the x is when y is equal to 12, then I'm just going to write 12 equals 3x, and I divide by 3. And we know that 12 divided by 3 is 4. Okay, so you should be able to fill in the others doing that method as well. Okay, on the next section, you're going to be writing a function to represent the situation that's given. And I know sometimes we have a hard time reading sentences and trying to translate them into an equation or an inequality, but do the best you can. So number 1 says, on the first day of his job, Mr. Jasper was given 10 client accounts. Every month he added 8 accounts to his list. Write an equation to represent A, the number of accounts that Mr. Jasper had after M months. So I'm going to start with A because A is going to equal the number of accounts. It said that he was given 10 accounts to start with, and then every month he added 8 accounts. So anytime you see an amount that's added per month or per day or per whatever, that's going to be what you multiply times your other variable. In this case, that's going to be M for months. Okay? So let me jump over here to number 3. 3 says electrician A charges $40 plus $25 per hour. Electrician B charges $30 plus $27.50 per hour. For how many hours would electrician A charge less than electrician B? Okay, so in the end, we're going to write 2 equations. So first one, A says an expression that describes the amount electrician A charges for a job that takes 8 hours. So I'm going to do a capital A here for this electrician. And it said that he charges $40 plus $25 per hour. Okay, so B is the same thing. Electrician B, it says charges $30 plus $27.50 per hour. Okay, so I'm going to scroll up here so that I can read the rest of question C. Okay, so part C says to combine your expressions by writing an inequality symbol between them, read the last sentence in the problem. Which electrician fees need to be smaller? So the last sentence said, for how many hours would electrician A charge less than electrician B? So if I take these 2 equations now, and I'm going to put an inequality symbol between them. So electrician A was 40 plus 25H. We're trying to see when is this less than electrician B, which would be 30 plus 2750H. Okay? In the next section, I'm going to show you how you can use your calculator to actually solve these types of problems. Okay, so the next section, this is going to work for inequalities and equations. We can do the same trick here. Now what I want to do is I want to go back and change my settings on my calculator so that I don't have to type in my own x values. So to change that, hit second window, and we need to go down here to independent and change this back to auto. You could also clear your calculator anytime and that will reset the defaults. Okay, so I'm going to go to y equals and I'm going to clear out the equation that's here. We're going to do number 1. 1 says 8x minus 28 is greater than negative 3 times 6 minus x. So I could sit here and show you how to solve that algebraically, but I want to show you a little trick on your calculator. So in y1, I'm going to type the left-hand side, which is 8x minus 28. And then in y2, I'm going to type the right-hand side, just as it is, negative 3 parenthesis 6 minus x. Okay? So I don't need to graph it. That's not what matters here. What I want to do is I want to go to the table and I'm trying to see when the y1s are greater than the y2s, because that's what the inequality says. When is the left-hand side of the equation bigger than the right-hand side of my equation? So I'm going to go to my table and I have these y values here and we're trying to see when is the left-hand side numbers bigger than the right-hand side numbers. Okay? So I can see that these first few numbers, and I could even scroll up to the negatives, but I can see that the y1s are actually smaller numbers than the y2s for a while. And then I get to a point right here at 2 where they actually have the same value. After 3, the y values in 1 are bigger numbers than the y values in equation 2. Okay, so the way that I'm going to write my answer then is I'm going to go over here and I'm going to say that x is greater than whatever the x value, 3. Actually, I'm going to back up. I'm going to say x greater than 2. Okay, because it is greater than 3, but it could be any number after 2. Okay, not including 2, but any number after 2. Okay, so anytime you're trying to compare two equations or two inequalities, you could put the left-hand side in one y equals and the right-hand side in the other y equals. Compare the table, and that will help you figure out, okay, is one bigger than the other, or when are they equal, whatever the equation is asking. Okay, now I'm not going to do number 4, but to help you on number 4, let me go ahead and draw the graph for number 1 here. So when you're graphing inequalities, whatever answer you get, that number needs to go in the middle of your number line. And you need numbers on either side of your number line. Your number line should always go increasing from left to right. Now since this says that x is greater than 2, we're going to put an open circle on 2. If it was greater than or less than, we would still do an open circle. Only when it's equal to, greater than or equal to, less than or equal to, do we fill in the circle. And then the inequality symbol tells you which direction to shade. Since it's greater than, I would shade to the right. Okay, now I'm on the bottom of page 41, number 8. It says we're supposed to write an equation or an inequality and then solve it. So this says for the Garcia's 25th anniversary party, a hotel quoted them a price of $400 for the room plus $19 per person for food. If they want to spend no more than $1,500, how many people can attend the party? So we're going to start out with the $400, that's the base price, plus $19 per person. It said that they want to spend no more than $1,500. So $1,500 is the maximum amount that they want to pay. So this amount that I've already written, 400 plus 19p, needs to be less than or equal to 1,500. Okay, it cannot be more than. It can equal it, but they can't be more than. Okay, so now we're going to solve this problem. So just like an equation, we're going to do addition and subtraction first. I'm going to subtract 400 on both sides. So 19p is less than or equal to 1,500 minus 400 is 1,100. And then the next step, we would divide by 19. Now remember, when you're dividing inequalities, if you divide by a negative number, that will flip your inequality over. Now for this problem, we're not dividing by a negative number, so that's not a problem. So if I divide 1,100 by 19, I get 57.89 and a whole bunch of other numbers. Okay, but we're talking about people here, and we can't have 0.89 of a person. So this is saying that the people needs to be less than or equal to 57.89. So I would go ahead and round down and say that the number of people would have to be less than or equal to just 57 people here. Don't round up to 58 because that would be too much. I would round down to 57. Okay, now I'm on page 42. I'm jumping to number 5. Number 5 says, for his birthday, JC received $85 from various out-of-town relatives. He wants to use the money to join a video game club. The fee to become a member is $20. Then he can rent games for $2.65 each. How many games can he order before he runs out of birthday money? Okay, so we know that he starts out with $85. Okay, so I'm going to come back and put the symbol in there in just a second. It's $20 to join plus $2.65 per game. It says how many games can he order before he runs out of money? Okay, so if we think about this, $85 is all he has. We can't spend more than $85, okay? So this amount on the right-hand side needs to be less than the $85, or the $85 has to be the bigger amount, okay? So now I'm going to solve. I'm going to subtract 20 on both sides. So 85 minus 20 is going to be 65, is greater than or equal to 2.65g. So then I'm going to divide by 2.65. So 65 divided by 2.65 is going to be 24.52. So this says G 24.52. Okay, so the games has to be less than 24.52. Again, you can't buy 0.52 of a game, so I would rewrite it, and I'm going to go ahead and flip the inequality over and say that the games have to be less than or equal to 24 games. That's all I can get. Okay, now we're on the last page, page 43. I'll do one of these. So number 7 says Mrs. Cantu planted 23 shrubs of 2 types in her front yard. She planted 7 more boxwoods than plumbagoos. Okay, so they're going to use silly words on this sometimes. It doesn't matter. We're still going to work the problems out the same. So they want us to write a system of equations that represents this situation. So they're telling us that together the 2 types were equal to 23. So that means B plus P has to equal 23. Okay? And then it says that she planted 7 more boxwoods than she did plumbagoos. So the number of plumbagoos equals 7 more than the number of boxwoods, 7 plus B. Now, we could solve this system. We could substitute the value that P equals into the other equation and find out how many of each, but on this section, they're not asking us to solve it. They just wanted us to write the system of equations, so that's all you're doing on this page.